Hello everyone, Anuruddha Kempitiya again. So today we will talk about another stoichiometry problem. This is also stoichiometry of a compound. So what do you mean by the stoichiometry? Stoichiometry is the quantitative relationship. That means the relationship between quantities. So when you get this kind of chemical formula, this is sodium in the hydrated form, sodium oxalate, hydrated sodium oxalate. So it has some waters of crystallization, some number of water molecule attached to one formula unit of sodium oxalate. So what kind of relationship indicated by this formula? Let's talk about that. You see the ratio between atoms. There are two sodium atoms in the formula unit. So we can get the atom ratio. So if you take one formula unit, you get two sodium atoms, two carbon atoms, six oxygen atoms, like that. Some hydrogen atoms as well. Now we can extend this relationship, the atomic ratio, to other quantities which are measurable in our chemical laboratory. What are they? Number of moles. Usually we deal with number of moles and masses of each substance, each atom, right? So mole ratio is exactly equal to the atom ratio, the particle ratio. Two sodium atoms and 2 mole of sodium atom. If you take 1 mole of formula unit, then we know molar masses. We can get them from the periodic table. The molar mass of the hydrated sodium oxalate is 170 grams per mole, and sodium molar mass is 23 grams per mole. So if we had 2 moles, that would be 46 grams, and 2 carbon moles, that means 24 grams. So these are the mole ratios and mass ratios, right? Then how do we use these relationships, these quantitative relationships in chemical calculations? Okay, this is one such example, one problem. You have 100 grams of sodium oxalate. It is an ionic compound and highly water soluble. When it is dissolved in water, the sodium ion and oxalate ion dissociates. So you get sodium ions and oxalate ion in the solution. So we can work out the quantity of sodium ion available in this solution. So if we dissolve 100 grams of sodium oxalate, what is the mass of sodium ion in the solution? So this is the problem. So this is one way that we can solve this problem. We will use this mass ratio. If we take 170 grams of the hydrated sodium oxalate, we will get 46 grams of sodium ion. So 170 grams is to 46 grams. This is the mass ratio. Now we can convert this 170 grams into 100 grams because the quantity given to us is 100 grams. So we can divide this by 170 both sides and then multiply by 100. So if you get 100 grams of hydrated sodium oxalate, we will get this much of sodium ions. That is the mass of sodium ion. So simplification gives us 27.06 grams of sodium ion. Okay, this is one way of solving this problem. We are going to use these mass ratios for this calculation, and we'll see how to use equation. for these calculations as well. This is very common method. Here, firstly, we have to work out the number of moles of hydrated oxalate. So, hydrated sodium oxalate, this is the way of getting the number of moles. Mass over molar mass, that is simple M over capital M, that is number of moles. We are going to use that equation. So, we are getting 0.588 moles. Now, the stoichiometry, only we are going to use the mole ratio. The mole ratio is 1:2. This is the mole ratio, 1:2. So, we are going to use that mole ratio. Then number of moles of sodium ion must be twice as this. So, we multiply it by 2. So, we are getting 1.18 moles. Now, we know number of moles of sodium ion, then we have to convert it into mass. So, we can multiply by the molar mass. There are number of moles into molar mass, that is equal to mass. So, we are going to use that equation. So, we multiply molar mass of sodium ion is 23 grams a mole. We know that sodium atom or sodium ion has same mass because loss of one electron does not change the mass significantly, very small change only, that is negligible, right. So, this is the mass of sodium ion. So, you are getting the same answer. We will take another example. We are going to use this quantitative relationship to calculate some other quantity. Here, this is the problem. There is a certain mass of sodium oxalate. Actually, it is in the hydrated form. Certain quantity of sodium oxalate. In that quantity, there is a 4.8 grams of sodium ion inside that. 4.8 grams of sodium ion. They are asking what is the sodium atom, what is the number of moles of sodium atom and how many sodium atoms, number of moles of sodium atoms and how many sodium atoms, right. So, we are going to use this relationship. Mass of sodium, that is 46 grams. Number of moles of oxygen atom, it is here, 6 oxygen atoms. So, when you see this formula, we can understand 23 into 2 grams of sodium atom, oxygen moles, 4 plus 2, 6 moles, 46 grams, and oxygen moles, 4 plus 2, 6 moles. So, this type of ratio, we can use this kind of ratio for faster calculation. Mass of sodium, sodium is to number of moles of oxygen. 46 grams is to 6 moles. Now, again, we have to convert this 46 grams into the given quantity. The given quantity is 4 grams. So, we divide it by 4, multiply by 4.8. Then we are getting 4.8 grams this side. So, this we can simplify. So, we are getting 0.63 moles. That is the number of moles of oxygen, 0.63 moles in this given quantity, right. Then we have to convert it into number of particles or number of ions. So we know 1 mole contains 6.022 times 10 to the power 23. Right, you may multiply the number of moles into 6.022 times 10 to the power 23. Then you are getting 3.77 into 10 to the power 23 oxygen atoms in that sample. And we can use equations as well. So we will see how to do that. Now we will solve the same problem using equations. The quantity given to you is 4.8 grams of sodium ion in certain sample of hydrated sodium oxalate. Then we can convert that 4.8 into moles. That is the usual method. So we are going to use mass over molar mass, this equation, then gives you number of moles. So you are getting this number of moles. Now we can always use the mole ratio, stoichiometry in terms of mole ratio. So number of moles of sodium is to number of moles of oxygen. Then that's here 2:6. That is the mole ratio. Mole ratio is equal to the atom ratio. Say 2 atoms here, altogether oxygen 6 atoms. 4 plus 2, 6 atoms. Then altogether 6 atoms. Then 2:6, that means 1:3. Now we have to convert it into the given the calculated number of moles. So we want to convert this 1 into 0.209. So you can multiply that by 0.209. Always the mole ratio that we know must be converted into 1. Then you have to multiply by the number of moles that is available. Right. So multiply this by 3, then you are getting the number of moles of oxygen atoms. Same mass as the previous one, and also you can get the number of oxygen atoms, number of particles, that is capital N. So we have to always multiply number of moles by Avogadro constant, then we are getting number of particles. So this is the number of particles or number of oxygen atom in the sample given to us.